Those who have joined the class may give their attendance in the chat box. I repeat, those who have joined the class may give their attendance in the chat box. Just wait for a minute so that I will present my screen. Uddesh, please respond whether my slides are visible or not.
Yes, sir, visible.
Okay, thank you. Okay. Good afternoon to all the students. In the last lecture, we were discussing regarding the design procedure of rivet joints. We have discussed what is a rivet, what are the different parts of rivet, how a rivet is specified, what are the different types of joints that are used in rivets, that is the lap joint and the butt joint. We also discussed about the different types of lap joint and different types of butt joint. What is the difference between these types? That also we have discussed in the last class. So I think that in the last class we have discussed till this topic. If you can remember, Uddesh.
Yes, sir, this was the last topic.
Okay. So in today's class, we will continue the same topic of rivet joint and we will discuss some more important points which you should keep in mind while solving problems related to gate. So the next topic is important terminologies that are used in rivet joint. First one is pitch. Then the second one is back pitch. It is also known as transverse pitch. The third one is diagonal pitch. And the fourth one is margin or marginal pitch. So let us understand one by one what are these terms. If you see, I am having a rivet joint, that is figure A, B and C represent single riveted. This is a single riveted lap joint. This is a double riveted lap joint. It is very much clear that two rivets are used to join the two plates. And this is double riveted zigzag joint. If you see, this is a zigzag joint, and this joint is also known as chain riveting joints. Fine. So what is pitch? Pitch is the distance from the center of one rivet to the center of next rivet measured parallel to the seam as denoted by symbol P. That is, it is nothing but the distance of the center point of one rivet to the center point of other rivet. So if you see, this is the front view of the rivet and this is the top view of a single riveted lap joint. Fine. These are what? These are the holes which you have inserted or which you have drilled in between the plate so that a rivet should pass through the hole. If this is the center point of one hole and this is the center point of other hole of the rivet, distance between the two center point, these two center point is known as pitch of the rivet. This is pitch P of the rivet. If I talk about the double riveted joint, then see, this is a rivet. This is what? This is nothing but a double riveted lap joint. This is the second rivet. In order to join this plate A with plate B by a rivet joint, you have drilled some holes in between the plates. Fine. If this is the center point of one hole of the rivet, this is the another center point of the second hole of the rivet, then in between the distance is known as pitch of the rivet. The same goes for this part also, that is the zigzag riveting also. This is the center point of one hole of the rivet. This is the center point of the other hole of the rivet. In between distance is known as pitch P of the rivet. Is it clear? Any doubt so far?
No, sir. Clear, clear.
Okay, next. Next is back pitch or transverse pitch, denoted by symbol PB or PT. Now, what is back pitch? It is the perpendicular distance between the center lines of the successive row of rivet. What is back pitch or transverse pitch? It is the perpendicular distance between the center line of the successive row of rivet. So if I see in the diagram, if I see in the first diagram, this is what? This is a single riveted lap joint. In this joint, there is no back pitch or transverse pitch is present. Why? Because in this particular figure, there is one rivet which you have used to join plate A and plate B. There is no other rivet. So if you see, this is what? This is nothing but the top view of the schematic figure. So in this top view, this is one row of rivet. If I want to define back pitch or transverse pitch, I need one more rivet. I need one more rivet. Then in the top view, you can see again one row of rivet. Then center distance between the two row is known as your back pitch or transverse pitch. But in the first diagram, that is in this particular diagram, which diagram? In this particular figure, this is what? This is a single riveted lap joint. In this particular diagram, back pitch or transverse pitch is not possible. If I consider the second diagram is double riveted lap joint or chain riveting. If you see, this is the front view of the schematic diagram and this is the top view of the schematic diagram. So in order to join plate A and plate B, you have inserted one rivet. But from the top view, if you see, this is what? This is one row of rivet. If you want to make the joint more strong, what you will do? You will insert one more rivet so that plate A and plate B is tightly joined. So if this is the second rivet, when you are looking from the front side, but if you look the same thing from the top side, you can see one more row of rivet. You can see one more row of rivet. if you see, this is the first row of rivet and this is the second row of rivet. If I consider the first row, this is the center line. This is the center line of the first row of rivet. And if I consider the second row, this is the center line of the second row of rivet. Intermediate distance between the center line of the two row of rivet is known as back pitch or transverse pitch PT. Is it clear? Any doubt so far?
Yes, sir. Clear, clear.
Fine. Okay. So if I see that in zigzag riveting, whether transverse pitch is possible, let us look into it. This is a zigzag double riveted lap joint. Fine. If this is the front view of the schematic diagram and this is the top view of the schematic diagram. So if I look this schematic diagram from the top end, due to this rivet, this is one row of rivet. Due to the second rivet, this is the second row of rivet, but this rivet is drilled in between the holes of the plate in such a way that it is making a zigzag rivet joint. Now see, if this is my first row of rivet, if this is my second row of rivet, then this is the center line of first row of rivet and this is the center line of second row of rivet. In between or intermediate distance between the center line of any two consecutive row of rivet is known as back pitch PV or transverse pitch PT. That means this distance is your back pitch or transverse pitch. Is it clear? Any doubt so far?
Yes, sir. Clear, clear.
Okay. That means you should keep one thing in mind that in single riveted lap joint or in single riveted butt joint, this transverse pitch or back pitch is not possible. They may give you four diagrams. Fine. And from that four diagrams, they will tell you that identify the wrong diagram in which back pitch or transverse pitch is not present. So if you know the concept, you can clearly take it. Okay. Fine. So let us move forward to the next terminology. That is the third terminology is the diagonal pitch. Now what is this diagonal pitch? It is the distance. What is diagonal pitch? That is, it is the distance between the center of the rivet in adjacent rows of zigzag rivet joint denoted by symbol PD. Again, you remember that this diagonal pitch is applicable only if there is a zigzag rivet joint. What is it? It is the distance between the centers of the rivet in adjacent row of zigzag rivet joint. That means I know that the third figure. I know that the third figure represents a zigzag riveted lap joint. Fine. If you see the position of the second rivet, fine. This is the first rivet. This is the second rivet. That means this is the first row of rivet. This is the second row of rivet. But the second row of rivet is, that means when you will drill the holes in between the plates, for mounting the second rivet, you have to drill in such a way that it is making a zigzag pattern. See, the center line of the rivet hole is making a zigzag pattern. Then in that case, you can define what is diagonal pitch. Then the diagonal pitch is defined as the distance between the center lines of the two rivets. This is the center line of the first rivet. This is the center line of the second rivet. When they are arranged in a diagonal fashion, that means this particular distance diagonally is known as your diagonal pitch PD. Similarly, this particular distance, center line of the two rivet, center line of the holes which you have been drilled in diagonal, that means this distance is your PD, diagonal pitch. This distance is your PD, diagonal pitch. This distance is your PD, diagonal pitch. Is it clear what is
Yes, sir.
diagonal pitch? So remember again, so this is your diagonal pitch. Any doubt so far?
No, sir. No, sir.
So can you tell me in the second diagram, that is this diagram, this is which diagram? This is my double riveted lap joint. In this diagram, can you tell me which one is my diagonal pitch? In the second diagram, can you tell me which one is my diagonal pitch? If you have understood the concept of diagonal pitch, tell me in the chain riveted joint, or that is in the double riveted lap joint, can you tell me the distance, which distance will be the diagonal pitch? Hello.
Yes, sir.
Tell me, Udesh.
Sir, in the second figure here, I am seeing the sir two rivets has been there.
Yes, then what? Then how I can, in the second diagram, how I can define diagonal pitch? This distance, if you consider, see, this distance will be diagonal pitch, yes or no?
Yes, sir. Yes, sir. This
Similarly,
distance.
this distance will be diagonal pitch.
Yes,
This much
yes.
distance is
Yes,
diagonal
yes.
pitch. This much
Yes.
distance is diagonal pitch.
Yes.
And this is your transverse pitch. This is
Yes.
your
PD.
normal pitch.
Normal pitch.
Okay,
Yes.
fine. The last one, the last terminology is margin or marginal pitch. The last terminology is margin or marginal pitch. Now, what is this margin? It is nothing but the distance between the center of rivet hole to the nearest edge of the plate, and it is denoted by symbol small m. Again, I am repeating, what is margin or marginal pitch? It is the distance between the center of the rivet hole to the nearest edge of the plate. That means, if you see in the first diagram is what? This is a single riveted lap joint. It is a single riveted lap joint. Fine.
Figure
So
number A.
yes, this is my margin. This is my margin. Fine. Because the plate is ending over here, and
Yes.
for this end, this is that line. No, so now it is defined as the distance between the center of the rivet hole to the nearest edge of the plate. That means if I consider the top portion, if I consider plate A, that means if this is my plate A, nearest portion is this edge, nearest portion is this edge, and if I consider plate B, Nearest portion is this particular edge. So from this edge to the center line of the rivet hole, this distance is known as margin M, or this distance is known as margin M. Is it clear? Any doubt?
Yes, sir. Clear, clear.
Similarly, if I talk about the second diagram, what is the second diagram? Second diagram is nothing but it is double riveted lap joint. Fine. Then if I need to define which distance is my margin, how I will define? So this is my plate A, and this is my plate B. If I consider plate A, nearest edge to the rivet is this edge. If I consider plate B, nearest edge to the rivet is this particular edge. Then from this edge to the center line of the rivet hole, this is margin, and from nearest edge to the center
The
line
center
of
line
the rivet
of this
hole
circle
for
we
the
are
second
considering
rivet
margin.
is margin M. This is margin M. Is it clear?
Yes, sir. Clear.
Fine. Similarly, if I talk about the zigzag riveting, and if I need to represent margin, this is my plate B, and this is my plate A. Nearest edge to this rivet for the upper plate is this edge. Nearest edge for plate B with respect to this second rivet is this edge. So what is my margin? Margin is the difference, is the distance between the nearest edge of the plate to the nearest edge of the plate to the center line of the rivet
Line of
hole.
the circle.
That means this is my margin M, and this distance is my margin M. Any doubt so far?
No, sir. Clear. Margin clear.
Okay, okay. So these are the terminologies which you should keep in mind, because these things we will be requiring while solving problems related to rivet joint. And always remember one thing in mind, that this margin M is always equal to 1.5 times the
Done.
shank diameter of the rivet. Always keep this thing in mind. Margin M is equal to 1.5 times the shank diameter of rivet. Is it clear? Any doubts so far?
Sir, clear.
Okay, fine. Next is rivet materials. Four options can be given to you given to you in GATE, and out of four options, they can ask you that which option is most appropriate for rivet materials. You should know. That means you have to remember these things anyhow. So rivets usually made up of mild steel. In most of the application, rivets are made up of mild steel. Normally, there are two variety of steel rivet bars are available in the market. One is your hot rolled steel rivet bars. Another one is high tensile steel rivet bars. Chemical composition of hot rolled as well as high tensile steel rivet bars are: carbon consists of 0.23%, sulfur consists of 0.05%, and phosphorus is 0.05%. Please remember these values. Fine. They can ask you that which option is what is the percentage of carbon in hot rolled steel rivet bars or in high tensile steel rivet bars? You should know. So you have to remember these values. Fine. These are what? Chemical composition of this hot rolled as well as high tensile steel rivet bars. And the most widely used material for rivet is mild steel. This also you have to keep in mind. Now, rivets
Okay.
which are used in corrosive atmosphere are made up of stainless steel. That means you are using a rivet to join any two metal and to join any two metal, and in that particular metal if any corrosion is there, that means during corrosive environment you use stainless steel in place of mild steel. And rivets are also used for connecting non-ferrous metals and soft materials made up of copper, brass, and aluminium alloys. That means non-ferrous and soft materials. If you want to connect any two non-ferrous or soft materials which are made up of copper, bronze, brass, and aluminium alloys, they are you can also do riveting. That means this copper, bronze, brass, and aluminium are what? These are these are the elements, or these are the elements which you will join by rivet. So if the composition of the element which you are joining by rivet is copper, bronze, and aluminium, then you can use this mild steel rivets to join the materials. Okay,
Yes, yes, sir.
fine. So these are the normally used rivet materials. So you have to keep these things in mind. Okay.
कोरोसिव एनवायरनमेंट होगा तो स्टेनलेस स्टील यूज करना पड़ेगा.
Yes, 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 yes. Okay. Let me see how many people have joined. Oh, only you are there. So Udesh, what I will do is that I will take the class till maximum 3:15. Okay. Because hello.
Yes, sir.
Fine. Because only you are there. Nobody else is there. Okay. Next topic is the failure of rivet joint. This is very important from gate point of
सर
view.
ये भी पूछ लेते हैं
This
कि
is very much
कौन
important.
सा फेलियर है.
What they will give you is that, see, many different types of questions can come in gate. The first type of question is they will give you the diagram and they will give you four options. Out of those four options, you have to take the correct failure option of rivet. Fine. Or else, second type of questions, what they will give you is they will give you in the form of numericals. Fine. You have to find out the efficiency of the rivet joint and many more things. Okay. So let
सर
us start the how a rivet joint can fail when it is in working condition. Normally, a rivet joint can fail in five different ways. Normally, a rivet joint can fail in five different ways. The first way is the shear failure of rivet. Second one is tensile failure of plate between two consecutive rivets. Third one is crushing failure of the plate, and the fourth one is shear failure of plate in the marginal area, and the last one is tearing of the plate in the marginal area. Fine. So what is your shear failure of rivet? How you can show it? If you see the first figure, the first figure represents shear failure of the rivet. That means this is what? This is your plate A, this is your plate B. You have joined both the plate by the help of rivet. So in altogether you can say that this is a single riveted lap joint. So on the first plate, if you apply a load, an axial load in, say, in negative x direction, and in the second plate if you apply an axial load in the positive x direction, then the cross section of the riveted will be subjected to shear failure. Is it clear? See, the shearing is occurring at this particular cross section. Shearing is occurring. This is the one of the criteria by which your rivet can fail. Any doubts?
No, sir, clear. Yeah.
Okay. The second type of failure is the second type of failure is
Self rating.
tensile failure of rivet, that is tensile failure of plate between two consecutive rivet. Read the line carefully. It is tensile failure of plate. That means failure of plate is occurring between two consecutive rivet. So if I see the second figure is nothing but the top view of a rivet joint. Fine. So if you see, this is one hole of rivet, this is the second hole of rivet, and this is nothing but the row of rivet, one single row of rivet. So what I told you, that tensile failure of the plate is occurring between two consecutive rivet. If this is one rivet, this is another rivet, in between the two rivet, what will happen if this is one plate? Behind this, beneath this particular plate, one more plate is there. So this is that second particular plate. Fine. Then if you say, if you apply an axial load of this plate in this direction and this particular plate in this direction, then what will happen? Tensile failure will take place in between two consecutive rivet. So this is the case of tensile failure of the plate between two rivets. Is it clear? Any doubt?
Yes, sir, clear है.
Okay. The third one is what? The third one is
Crushing failure of the plate.
crushing failure of the plate. That means, say this is one plate. This is the second plate. Both the plate you have joined by rivet. Assume that this is that hole of the rivet. That means how it can fail? If you apply a crushing load. Fine. If you apply a crushing load for this particular plate in this direction and for this particular plate in this direction, what will happen? This hole of the rivet will try to elongate. How it will elongate? This diameter. This is what? This is the diameter of the hole. This diameter will become bigger and bigger and bigger. If the diameter will become bigger and bigger and bigger, what will happen? After a certain interval of time, this hole of the rivet will not be present. Yes or no? It will not be present. So that means what is happening? That means this crushing of the plate is happening due to elongation of the hole. See, due to elongation of the hole. This type of failure is termed as crushing failure of plate due to elongation of the rivet hole. Any doubt so far?
सर ये एक बार और फिर से एक्सप्लेन कर दीजिए सर क्रशिंग वाला.
Okay, how a crushing will take place? Say this is one plate. Fine, this is your second plate. Both the plate you have joined by the help of rivet. How plate can fail by crushing if due to application of this external load on the two ends of the plate. Fine, there is a tendency that this hole will elongate. That means this is the hole. After certain interval of time, when you apply the load, what will happen? The hole will try to elongate. Hole will try to elongate. Fine, elongate from all the ends, from all the direction. So after certain interval of time, what will happen? This hole will not be present. If this hole is not present, that means what happened? Hole is being crushed, due to which the crushing failure of the plate will take place. Is it correct?
Clear, clear, sir. Clear, clear.
Okay, so this is the crushing failure of the plate due to elongation of the rivet hole. Next is what? Next is shear failure of the plate in the margin area. Shear failure of the plate in the margin area, that is depicted by the fourth figure. I know that this is what? This is the top view of the plate. Fine. This is the rivet hole, and if I assume that this is that marginal, this is that margin, that means this is the region of the plate which is nearer to the rivet. Then what can happen? The shear failure of this margin can take place due to axial load on both the plates. Is it clear?
Yes, sir. Clear.
So this is the shear failure of the plate in the marginal area. And the last type of failure is the tearing of the plate in the margin area. That means, see, that means what can happen due to the presence of stress concentration present in the plate is getting teared along the marginal area. This is the fifth way by which your rivet joint can fail. That is tearing of the plate near to the margin area. Is it clear? Any doubt so far?
Clear, clear.
Okay, okay, fine. So okay, so I think we can stop over here. In the next class, what we will do is we will try to find out the equations which are responsible for failure. We will find out some equations, and those equations are called strength equations. Those equations are nothing but the design equations. By those equations you can design the rivet joint. This we will try to this we will do it in the next class, as well as we will try to find out that what will be the efficiency of a rivet joint. And by efficiency I mean how longer this rivet joint can sustain different types of load before failure. Fine. Okay.
Okay, sir. Okay, okay.
Fine. So with
सर
this,
अगले दिन डिजाइन वाला स्टार्ट करेंगे ना.
yes. From next class,
डिजाइन.
what we will do, we will do the design part of this rivet joint, and then we will solve some problems which has been
न्यूमेरिकल
asked in
प्रॉब्लम.
the previous years
ओके.
of GATE. Okay.
ओके सर. ओके, फाइन.
Okay, fine. So
थैंक यू.
with this, I am ending the lecture over here. Fine. Thank you. We will again meet
थैंक
in the
यू.
next class.